Hello my lovelies, it's Susanna, and today I want to show you how to find all solutions of this equation, including complex solutions. We have x to the power of 3 plus x to the power of 2 is equal to 36. As soon as you have x to the power of 3 in your equation, you usually need polynomial division to be able to solve for x. But before we can use polynomial division, we first have to bring everything to one side of the equation. So let's subtract the 36 here on both sides of the equation, so that here we have our x to the power of 3 plus x to the power of 2 minus the 36 now, and on the other side this cancels out and we get 0. Now that we have everything on one side of the equation and a 0 on the other side, we can guess a first solution. This is not a joke, it's really the official method. You have to guess your first solution of your equation. So you start by trying a 1 and see if you insert it here for every x, if this solves the equation. If not, you try a -1. If this still doesn't work, you try 2 and a -2 and so on, and just hope that one of these candidates will solve this equation. So let's try the 1 first. We have 1 to the power of 3 then plus 1 to the power of 2 minus 36, and the question is this equal to 0? No, it's not, because 1 to the power of 3 is equal to 1, 1 to the power of 2 is equal to 1 still. This is not 0, so the 1 doesn't work. What about the -1? Well, if we insert -1, we have -1 to the power of 3, which is -1. -1 to the power of 2 is still 1. This is still not 0, so this also doesn't work. What about the 2? 2 to the power of 3 is equal to 8, and 2 to the power of 2 is equal to 4. No, still not 0. The -2, the same thing, because the only thing that changes is here, the sign, so it would be -8 here, still not 0. What about the 3? We don't lose hope. We have 3 to the power of 3, which is 3 times 3 times 3, which is 27. And here we have 3 squared, which is 9. Ooh, this looks good. This is actually equal to 0, so we found our first solution. X is equal to 3 is a solution of our equation. Let's take this information with us here now. We still have our equation, but we also have a first solution, and we can use this solution now to start with a polynomial long division. For this, we only take the left side of our equation, so I'm going to erase this. Then we write this in parentheses, because now we want to divide, because of the division, all of this by the following. Here you always write down x minus, and then you insert your solution. So we're going to insert the 3 here, and now we want to calculate this. This is now the method of the polynomial long division. For this, you take the second part here first, so the x minus 3. Then you write down something like this, and in here you write down your first part, so the x to the power of 3 plus x squared minus 36. And now we start with the division. You always start in here with your first part, and you divide this only by the x. So if you divide always only by x. So if we have x to the power of 3, let's write it down here. We want to divide this by x, which gives us x to the power of 2 as a result. So you write down your result up here. And now we have to take this result and multiply it by all of this here in the front. So if we multiply, then we multiply by everything here. Then let's multiply. So we have x squared times x first, which equals x to the power of 3. We're going to write down our result here. And then don't forget that there is more. So we have x squared times negative 3 here as well, which equals negative 3x squared. And now we're going to subtract this from this part here. So we have x to the power of 3 minus x to the power of 3, which cancels out. Then we have the x squared parts here. So we have 1x squared minus minus, which gives us a plus 3x squared. So one of them plus 3 of them equals 4x squared. And the minus 36, we don't subtract anything, so it just stays minus 36 then. And now we repeat all the steps with this first part. So we take this green part and divide it only by the x. So we have 4x squared over x. One of these x's cancels out and only 4x is left. So we take this result and write it here on top. So plus 4x. And now we have a new orange part that we're going to multiply again. So 4x times x equals 4x squared. And 4x times negative 3 equals negative 12x. Now we're going to subtract again. 4x squared minus 4x squared cancels out. And now we have to be really cautious here, because here we only have a number and we want to subtract something that has an x in here. This is not possible. So I would recommend to take your number and write it down here with a little bit of space so that you can add that you have no x in here. So you have 0 times x here, and now we do our calculation. So 0x minus minus, which is plus 12x, equals 12x in total. And then we subtract the 36 at the end. We are not done yet. We repeat all the steps now with this first element. So 12x divided by just the x. What do we get if we do this? This cancels out and only the 12 is left. So we add a plus 12 here. We have a new orange element and we multiply. 12 times x equals 12x, and 12 times negative 3 equals negative 36. We subtract again. 12x minus 12x cancels out. Negative 36 minus minus, so plus 36 cancels out. We get a 0, which means we are done now with our division. We have a result now. This thing here, this entire thing, is our result of this division. So we take this new function that we found here and set this now equal to 0 so that we have a new equation. We keep in mind that we already found a solution, but we want to find more solutions with this equation now. So this is our new equation. It's a quadratic equation, so we can use the quadratic formula to find more solutions. Let's write down the quadratic formula again. We have minus b plus minus the square root of b squared minus 4ac over 2a. What is my a here? What is my b? And what is my c? A is always the number in front of my x squared. It's just a 1 times, so it's a 1. B is the number in front of my x, it's a 4, and C is the number that doesn't have any x, so the 12 in our case. Let's insert everything. We have minus, B is 4, okay, plus minus the square root of, B is still 4, so 4 squared minus 4 times A is 1, times c is 12, and down here we have 2 times my a is 1. Let's calculate a little bit. 2 times 1 is equal to 2. 4 squared equals 16. 4 times 1 times 12 is 48. So we have 16 minus 48, which is equal to negative 32. So we have a negative number in our square root, which is fine because we also have to find the complex solutions. So everything is okay. We will get 2 complex solutions here. Let's write down the first one with a plus. So our first solution is the negative 4 plus the square root of negative 32, and all of this over 2. And the second complex solution is the same thing with the minus. So we have the negative 4 minus the square root of negative 32, and all of this also over 2. We still have to simplify these solutions a little bit to get the standard form of a complex number, but so far we have a first solution, don't forget about this one, a second solution, and a third solution. Let's take these two here and let's simplify them a little bit. Let's start here. We have one big fraction, but because of this plus, we could write this one fraction as 2 separate fractions with a plus in between. Here we have negative 4 over 2, and with the second we have the square root and all of this over 2 here as well. Negative 4 over 2 is equal to negative 2. And what can we do here? We have a square root here. Here we don't have a square root. But we could write the 2 as the square root of, and then we only have to square this number, so we get a 4 in our square root. So instead of the 2, I am going to write down the square root of 4 here, because now we have a fraction of 2 square roots. We can write this as one big square root and write the fraction in here, so that we have negative 32 over 4. And if we calculate this now, we get negative 8 in here. And to find the standard form of a complex number, you don't want to have negative numbers in your square root. So what you usually do is to write this number here as negative 1 times 8. And now you have a product in your square root, so you can write this 1 square root as 2 separate square roots that are multiplied by each other. We have the negative 1 in here and the 8 in here, and now this square root of negative 1 is the imaginary unit I. So instead of this part here, you replace it by I. And then there is one last thing that you usually do. You switch these two. So you have your I usually at the end and the number in front of it. So this is the algebraic form of a complex number. And there is one tiny little thing that you could do. It's not necessary, but let me know in the comments if you would have done it. You could write the square root of 8 as, so instead of the 8, you can write 2 times 4, and then you can calculate the square root of 4, because the square root of 4 is equal to 2. And then you only have the 2 here left in your square root. So instead of the square root of 8, we could write it as 2 times the square root of 2. But as I said, it's not really necessary. But this is our first solution here. We have another one here. We could do the same steps with this one. The only thing that changes is this minus here. So we would get in the end the -2 as well, but not this plus. So we would have the minus instead, but then we would have the rest here as well. So in total, for our equation, we have found these 3 solutions. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!